So welcome everyone to Coffee and Cloud. Today's session is about blockchain data and AI on Google Cloud. And as some of you know, we are running the Coffee and Cloud sessions on a monthly basis. And last time we covered blockchain node hosting. So if you have ideas for upcoming sessions, please email us at coffeeandcloud@google.com. So we're going to do quick intros next. We are all members of the Google Cloud for Web3 team. So my name is Bertrand Portier. I am part of the Google Cloud Customer Engineering team and the principal for Google Cloud Digital Assets. So in Digital Assets, our team's mission is to support our customers for building, transacting, storing value, and deploying new products on blockchain-based platforms. So with that said, I want to invite my colleagues, Devan, Nalin, and Brice to introduce themselves.
Okay, good afternoon, everyone. Good morning, GN. My name is Devan Mitchem, based here in sunny tropical Singapore, though it is beginning right now. And I'm part of the Web3 product team here at Google. Pleasure to meet you all, and thank you all for joining. Pass over to Nalin.
Nalin, I think you were on mute.
Sorry about that. Hey, I'm Nalin. I've been with Google for about 7 years, based in the Bay Area, and I'm leading Web3 products in Google Cloud. Over to Brice.
Thank you, Nalin. Brice Perez here. I work with the Google Cloud Digital Assets team, basically a customer engineer for all things Web3 and heavily focused on data analytics. So glad to be here for this wonderful topic. And thanks for everybody for joining. Bertrand, you're on mute as well.
This is that was a moot point. Okay, this is what we planned for today. Today we're gonna have lots of demos. So typically we have about like 25 or 30 minutes worth of contents. We may have a little bit more today because we have quite a number of demos that we want to show you. But this is what we planned for. So we're going to start with why you need blockchain data, and then move into the blockchain BigQuery datasets. And these are public datasets, and I will do a quick intro on what they are, the background, etc. And then we'll show you a number of demos that leverage these datasets. After that, point number 4, we are going to cover the future, like a bit of what we are thinking in terms of products related to blockchain data and analytics, and then do Q&A and share a few resources at the end. So during the Q&A, feel free to unmute, feel free to use the chat, or even better, use the like the Q&A like chat feature that we have at the bottom right of the Meet screen. Okay, so let's get going. So today, like I said, you're going to see demos based on the blockchain data that's available for free in Google Cloud BigQuery. So now in this audience, you are probably very familiar with the challenges of blockchain data. And what I wanted to do is to quickly go over, number 1, why blockchain data is needed, and number 2, what qualities are required for that data to be useful. So if you look at number 1, what are the use cases? Large language models, AI, ML. That's a really big one, right? There is so much hype about LLM Gen AI today, but that's so true. Like I recently attended a research summit that was hosted by Coinbase on blockchain and AI, and it was mentioned during the summit that 80% of the challenge is access to blockchain data. So that's a really, really big one. And then we have analytics, and that applies to layer 1s, exchanges, or really any dApps. And because of these data needs, a lot of companies today end up running their own RPC nodes or archive nodes. And we know that that comes with challenges, right, around the hosting infrastructure, the time to sync, etc., etc. So the question is, like, what would be required of the off-chain data for you to use it, right? What would be the what will be the features or the aspects of the data, what will be your requirements for you to use it. And this is when we can go about the data needs, right? We have a few points there. So availability, super important, right? How fresh is the data? How far behind is it from the tip of the chain? Right? How fast can I access the data? What is the latency? Once I access it, how complete is it? Right? Do I have all the information that was captured in the block? Do I have transactions, logs, dates? Like, is it really complete? Can I trust the data? Right? Can I trust the integrity of the data, that it hasn't been tampered with between when it was taken off of the blockchain and between when I access it off chain? And then we have different types of use cases that we mentioned, and we need for that data to be agile and support these different use cases. And of course, we need for this to be affordable. And if it's really high quality data, but it's not economically viable, then that's not going to be useful. So these are just a few stuff on blockchain data, why you need it and what qualities it requires. And with that said, I'm going to move down to the next section and introduce the BigQuery public datasets. So as you can see on the screen now, these datasets allow you to SQL query chain data without the need to run blockchain nodes. You can run SQL queries without having to run blockchain nodes, right? And you can get blockchain data, blockchain insight from that. So the way we've done that, we're going to go left to right, right? You start with the green, right? We run blockchain nodes from the major chains. And from those nodes, then in yellow, we extract the data using an architecture that's actually available. And there's a link to it called blockchain ETL. And we do that on a regular basis. For example, you can see there, like for Ethereum, we're about like 4 minutes or 20 blocks behind the tip, right? And then it's pretty up to date. It doesn't have a specific SLO, but we are pretty up to date on the data that you get. And then what we do, we extract it and then we store that right in Google Cloud BigQuery, and we make it available for free. Right, so we basically we pay for the storage cost, and then you only pay for the queries that you run. So that's what that is. It is available from the Google Cloud Marketplace, and it's been available starting in August 2018. So that's quite a while ago. And this is managed by our developer relations team and supported by as an open source project. And what I wanted to do next, right before I hand over to the rest of the team for demos, I just wanted to ask you a question, and that's what highlighted in yellow here. Which Ethereum tokens or ERC20 contracts have the highest number of transactions? That is the question. Which Ethereum tokens have the highest number of transactions? And when you think about it, what I'm going to do here, I'm going to go to BigQuery, and I am going to actually run this query. So here you can see that I've got the SQL statement to interrogate the. I'm going to start it now to interrogate the data sets, and basically I'm going to select the contract address right from the BigQuery public data crypto Ethereum contracts, and I'm going to join that with transactions. I'm doing a join, right, and then I'm going to see what result it gives me, right. I'm going to limit that to only 10. Okay, so now the query has run, and then it gave me that specific address, right. And let's see what we have here in the chat for USDC, USDT. All right, so let's have a look at this. Now, for now, I'm just very bare bone. I'm just going to go to Etherscan, right? And then I'm going to check that contract address, right? That's the address here. And then it corresponds to a contract. Yeah, that's the other, right? So USDT. So that's what it is. So just very, very basic, but basically I could get to that answer, right? I had a question, right, about this, and I can get to the answer in seconds. I didn't have to run blockchain nodes. I didn't have to do anything like that. And I can get some insight from the blockchain. right? So that's what it is. So let me just go back to this here. So we have links, we provide links as well to the architecture behind this. And then there is also a hands-on lab that you can do to do similar things yourself and do more interesting queries. All right. So that's just to give you like the power of this, like the power of these data sets is that you can join, or you can join multiple tables, right, from these crypto data sets, but you can also join these data sets with other data sets of your own, private data sets, et cetera, et cetera. And that's really the power behind that data. Okay, so now a little bit of an orientation. The next section is going to be the most interesting one. I'm going to get out of the way. We're going to see demos. So Brice is going to start by showing a little bit more about the data sets in BigQuery, as well as how a quant modular data scientist will actually leverage those in their day-to-day. And then to as well a little bit of Gen AI or natural language queries. So you will see that. And then after that, Devan is going to show examples of organizations that have used these data sets to create pretty cool dashboards out of those. With that said, I stop presenting and I hand it over to Brice.
All right. Thank you. Thank you, Bertrand, for that. I'll pull up my screen. I won't spend too much time here, but I have the BQ Explorer, and you've seen a little bit what Bertrand actually showed you. This is basically within GCP console and allows us to explore those data sets. So Google's mission is to make data universally available and accessible and useful, as Bertrand mentioned, and blockchain data shouldn't be any different from that. So I can show you the crypto Ethereum over here on my left. And then you see crypto Bitcoin. It's only showing the starred ones, of course, but there's plenty of different other ones that you can look at inside of our public data set. But then you can actually look into the balances and traces, tokens and transactions. And then you'll actually find useful information here based on if you really want to understand this data, is some useful descriptions there so that you can actually get some better understanding of the schema. But let's say if you are a data scientist or you want to have a little bit more organization in how you query your data and you want to take it a step further. I know many people have heard of Juniper Notebooks, Colab, but we have what we call Vertex AI, a workbench. Before I go there, I'll show a diagram of the relationships between these tables. This can be really accessible. I can share this with anyone who's interested. And basically one of the top or the most important data sets or tables within the relationships is usually the block hash and the token address. Usually it's used the most to try to tie those data sets together. And this is a Vertex AI workbench. So we have a managed notebook. You can easily use user managed notebooks. The managed notebooks gives you a little bit of flexibility as for when to shut down a machine that is running the Python notebook. And also if that you want to scale up, scale down on that notebook, but not have to worry about upgrades. Now, I have my notebook already opened, and what I have here is a few queries. But let's say you don't want to go back between multiple tabs and going back and forth between BigQuery and also the notebook itself. Let's make it where it's more integrated. It's easy to access that information. And yes, you can easily pour or pull in a SQL statement into a data frame. But what I'll do is you'll see an icon here where it has the BigQuery symbol. It's basically an in-cell editor, and it'll allow you to quickly submit a query right inside your notebook from BigQuery without going back over to the Explorer. It's letting me know that this query will be processed. It's giving me information that, and additional information will show up if there was an error as well. Now, sometimes I can click this once, or sometimes it'll probably have to be twice, but I'll go ahead and click that, and I'll start on the next queries as well while those results are building up. I'll make sure I go back up and see if it's ready. Yep, the query results showing here for this particular query. It is basically what are the top wallets by transaction value and how has this changed over time? And then, in addition to that one, what are the 10 most popular Ethereum collectible tokens? ERC 721, which we know as NFTs. And then similar question that what Bertrand actually ran before. Now submit that query. While that's running, you can actually see right at the very top where if you decide that maybe the query is not getting you the results as you like, you have a large query that usually requires a little bit more compute. With Vertex AI Workbench, you can change and modify the hardware on the fly without having to leave your workstation or the notebook itself. So it gave me the results for this, but say if you wanted some more visualizations around that, you can see that there's opportunities to connect with BigQuery, et cetera. But then let's say if I didn't want to utilize BigQuery, but I wanted to do the old-fashioned way of bringing the SQL statement into a data frame and then producing a visualization with what plots and Seaborn. So I'll run this. Actually, I'll run all cells. And I see information towards the bottom saying that my kernel, the Python that's currently running, is busy, is computing that information. It should give me the results soon. And now I have visual representation of this particular query. And this one's calculating average daily gas prices for Ethereum transactions over the last 30 days. I also have a query here, a little bit more heavier. This will take much more time in certain situations, but I decided this kernel would run with TensorFlow to give me some benefits there. And I will go ahead and start running this one. Now, this one will take a little bit longer, and we'll come back and visit it, but I'll let that run. But let's say if you are not familiar with what query you want to run, you have a hard time maybe coming up with some foundations or trying to get started. So the beauty of Vertex AI is that we have a Gen AI built into the interface, so it's easily accessible, taking it a step further with that information to basically speak to your data in plain English, in a sense, and plain text. So I go over to Generative AI Studio, and I'll click on language. We have various different prompts to get you started, whether it's structure or free form. But to save time, I have my prompts here that I already saved, and I'll look at the average gas prices over the last week. So I already pre-wrote a query here, or a prompt here, and then it will generate a query for me. Now I have a full SQL query that it just generated for me based off of my question. I'm going to go ahead and make sure I copy everything that's needed. I'm going to take it back over to BigQuery, start a new SQL workspace. I'll paste that and run this query.
And Brice, while that's running, maybe you can just read the prompt.
Yes, I will do that. I'll go back. So based on the BigQuery public data set, crypto_Ethereum dataset, generate me a SQL query that shows average gas prices per day using block timestamp for Ethereum transactions over the last week. And that query should be finished, yes. And so it's giving me the information here. Average gas prices there. And then I mentioned that my notebook, it should have the visualization, or it's still running. For this plot, we can always revisit that. But yeah, so now you see the benefits of basically utilizing Gen AI Studio and allowing us to look into blockchain data, not only making it accessible for data analysts and data scientists, but you can incorporate it in such a way where you can actually ask plain text questions to get the query to get you going. At this particular time, I'll pass it over to Devan to actually go even further and show visualizations around using a blockchain data for insights. Devan?
Awesome. Thank you, Brice. I don't know how I can follow up a Gen AI demo, but I'll try. I will present from my screen. And before I get into the specific demos, as Bertrand said, in terms of where can this take you, right? I'll walk again just through another overview of context setting here. So let me bring up my screen. So we're all familiar with Etherscan, Ethereum every couple seconds. Typically every 6 seconds, we have a new block. And as my page loads here, we'll try and tie this together, right? So here we have a kind of a list of the recent blocks. As we all know in this space, blockchains are pretty finicky. They might split, they might uncle. So we're going to go back maybe 5 or so minutes and find the latest block, and maybe not the last block. Go to a few minutes ago, and let's just pull out maybe one of the later Flashbot builds, or here we go, rsync. So we'll just grab this block here. And again, we're going to go to our BigQuery data set. And for those on the call that might not be familiar with where BigQuery is located, again, it's just on the side panel here under SQL Workspace. And what we can do here is bring up, I'll cheat a little bit and have some queries already preset. I'll throw in a query here for the latest block. And you can get a sense here again of some of the investigative powers of what's in BigQuery and really poking around inside these blocks. And you can see here that within this block, we have all these transactions, and this will map up one for one with what you see on Etherscan. But what's really interesting here is this input column. And one thing that we're indexing is not only what's happening on chain in terms of block information, nonce information, transaction IDs, you name it, but actually the smart contract calls inside these blocks. And there's some pretty powerful things you can do with that. And I'll dive a little bit in here in terms of what that means. So this simple query here can pull some high-level data, but what if we want to go a little bit deeper? Well, let's take one example of an NFT project, and we'll pick maybe Bored Apes here. On Etherscan, everyone here might be familiar that you have contracts, all the source code is posted online. What we can do here is you can actually go through the contract ABI, and Google's crypto public data sets also indexes this ABI data. So for those of you on a call, shadowy supercoders, you can go through here and actually search for function calls, again, within BigQuery. And I'll do a little demo here in terms of what that means. So if I go back, let's do a general search on every transaction that engages with this smart contract. And to do that, all you would do is you would take the address of this smart contract, which is in the case of Bored Apes, it's this 0xBC. We can query BigQuery against that smart contract and see all interactions with that smart contract. So this should yield things like every token transfer, et cetera, et cetera. And it looks like I did a typo somewhere here. Yeah, deleted a word. Where'd it go? Magic undo here. Yeah, we'll just get rid of this. Okay, so we'll run it again. And again, this should just show every interaction with a smart contract. And this is one of the building blocks you can take in terms of building dashboards or powerful insights here. And what you can see here, once it loads, it's just finding all transactions in the past day or so. It'll show results of every interaction with the NFTs on the Bored Ape smart contract. Okay, so you can go through here and again, look at just insights unique to that smart contract. So if you have maybe a project team building NFT projects, or say you're working with DeFi protocols, you can really narrow your query into specific smart contracts. But let's take this a little bit deeper. Can we do something a bit more powerful? There's another example here where you can go a little bit deeper into the actual contract data on these smart contracts, and I'll try and make my screen a little bit larger here for folks. But this is a more advanced reference here, and I won't get too deep into this call, but you can Google Ether.js and how BigQuery supports something called user-defined functions. And what we have here is a powerful JavaScript function embedded in our SQL query that actually pulls the contract API info I was sharing earlier. It'll actually pull, I've pulled some of the contracts here, dumped it into my BigQuery query string, and effectively just highlighted that, hey, look, show me specific contract calls to the Bored Ape smart contract. And in this case, show me all the details in terms of transfers and transactions. So when I run this query, and just for the sake of time, I'm not going to run it again, but you can see the results here. You can see the same detail I showed you before, but if you squint, you'll actually see decoded data in the form of a key value array. And you can split this and get things like token ID and some of the to addresses and other unique details, again, within that smart contract. So what does this mean? Well, let's take the word of Nick Johnson, who runs ENS, and he had this great quote around how the Ethereum name service, they use BigQuery and Google's public data sets to run some of the dashboards for the Ethereum name service protocol. Now, what's that look like? This is public. We can load it up here, and you can see that the ENS Foundation has published using crypto public data set data, literally almost a real-time business dashboard of their protocol. And what's really interesting is this chart here, which shows every calendar day that passes, there's around 3,000 years worth of ENS names that are registered in a given day, which is pretty fascinating. So these teams, these DAOs that really build, native to Web3, they can look into this public data set and really look at the really just the on-chain, organic, completely trustless, permissionless business metrics and really bring that to life. And this tool right here is Looker dashboard. Now let's think of other contexts. This is in the case of a DAO, maybe how you can bring this, have this public data set, really do some heavy lifting for you. What about if you're maybe a gaming startup? Well, in the case of one of our customers, Axie Infinity, they used to run on the Ethereum network, and we built this little demo a couple years back. But this can pull, based on what's happening on game and on chain, pull up really interesting insights in terms of analytics, right? Because again, if these gaming items, these digital assets are NFTs, those can be tracked, again, just by going through the smart contract. So you can pull up really interesting insights on maybe top selling NFTs. You can pull up some interesting insights, maybe for your data team or your partnership team. That might find value in less technical, less intimidating dashboards where you can find insights with a bit more context. And another idea, just in the case of marketing, and we haven't really touched on that topic here, but if you think of user engagement, this is obviously a popular area when it comes to Web3 and Web2, frankly. You could build dashboards that look at individual addresses and how they interact with your smart contract over time. So in this case, this user wallet was quite engaged with the smart contract back in 2019, but then went radio silent over 2020. That's interesting. However, this user right here, she or he was involved early on, went quiet, but then started to come back and play the game. This might be interesting if you tie this into your Salesforce or some of your outbound CRM systems to really mesh that Web2 data with your Web3 data, the on-chain metrics of your users, and really bring in insights, again, around user engagement, user acquisition, et cetera. Okay, a third example, NFT art galleries. So there's an exchange called Async Art, and they can look on-chain and look at maybe top collectors over time and find all the collectors that might win auctions of rare, maybe one-of-one artwork or JPEGs, and maybe synthesize that with maybe Google Sheets or, again, other auction data sets that they have, and run interesting metrics in terms of maybe what time of day are these auctions running, or what quarter are we seeing the highest activity when it comes to art sales. Okay. So that's just a quick glimpse. I'll pass it back to Bertrand, but feel free to send us any questions in the comments. Thanks.
I'll actually jump in here. So those were awesome demos. Thanks, Devan and Brice and everyone that showed the power of what you can do when you have blockchain data in a SQL accessible format, right? There's lots of ways to create queries and also visualize that data. So, they showed you what we have today in our BigQuery data sets. But what we've heard from customers is an opportunity to go even deeper on EVM data sets. So if you want to go to the next slide, what we're doing now is our engineering team on our infrastructure is re-indexing a lot of the Ethereum data, which will apply to a lot of the EVM data sets as well. And what we're going to do is provide an SLA on freshness and accuracy. we note that that's something missing today if you're going to build mission critical applications. We're going to enhance our classification of contracts, so a much better understanding of what's an ERC 20, 721, 1155. We have tokens today, but maybe not as comprehensive as the market needs. So that's what we're working on. We'll also compute balances for all wallet addresses for both fungible and non-fungible assets. So make it really easy to understand for a given user what they're holding. And then something else that's been highly requested is, as you may or may not know, BigQuery doesn't support UINT 256 data type today. And that's a pretty key piece for blockchain data. So what we're going to do is also offer lossless string representations of that data, along with UDFs that let you interact with those strings as if they were numbers. So I think the combination of those will be a suitable workaround until we have native UINT 256 support inside BigQuery. And this data set is scheduled to preview in July. So if you're interested in that, reach out to us, and we can make sure you get access as it becomes available. And then as we did our Ethereum data sets and as we were revamping them, we came to the realization that to support all of the blockchains we want to support over time, we won't be able to really do that all on our own. And so we're thinking about building, or not thinking about, but we're actually designing and building a data platform. So if you want to go to the next slide, what we're doing is we're building a platform that allow L1s and L2s to integrate with us. This will help us scale to all the chains we care about. And what developers will get that are building on these various blockchains is they'll get, their historical data via BigQuery and SQL, which is what you saw today, real-time data through PubSub, so you can, subscribe or listen for real-time data as it's happening in a much more reliable way than maybe WebSockets on RPC nodes today. And then you can imagine this will also be the gateway for Google to leverage blockchain data throughout all of its products and services. So this is, we think, a really exciting opportunity for L1s and L2s and developers. And we hope to be part of the go-to-market plan for basically any blockchain going forward. And this data platform, we're planning on having the version 1 available at the end of the year. That'll really be for L1s and L2s and third parties to start integrating with us. And then, getting into 2024, we hope we'll have like a really nice cross-chain platform that'll allow you to execute queries across the board. Do you mean only EVM chains by relevant chains? No, the data platform is meant to support non-EVM chains, right? So right now, all of our chains are not EVM based. And I can mention we're working actively on Solana. That'll be out in the next quarter or so. We'll be working on many other non-EVM chains as well. So this is not meant to be EVM specific. Although, there is a lot of relevant chains that are EVM based, which we call out. So our first effort, when I talked about us redoing the Ethereum data set, that'll apply more to EVM based chains, but the data platform is meant to support all kinds of chains. And it'll start normalizing, it'll provide a higher level of abstraction so you can understand like accounts, contracts, balances across chains and do cross-chain queries. So that's really the goal there. That's all I really had there. Thanks for hearing about our future plans.
Thank you, Nalin. And thank you, Devan and Brice, for the awesome demos. Hopefully, you start to see the power of these data sets and what we are planning for the future. So what we're going to do next, we're going to go and you can follow under the activities on the bottom right? And we're going to go and answer the questions that were raised. And we're going to do that in the order of the upvotes, right? So how many upvotes, right? We're going to do that first, right? So the first one is from Zach. And the question is, are any of the tools or demos seen today packaged in a public template which can be shared? So I think the basic SQL queries, right, that I showed at the beginning, yes, these are available, right? And these are available as examples, and you have a few other ones there. And then I will let Devan maybe talk a little bit more about what he showed. And then I think Devan is having sound issues, but yes, we have a number of like GitHub repositories. We have example SQL queries, example dashboards, etc. I will make sure that we share with you like links to those assets. So the answer is yes, and we actually want for the community to also contribute, right? As you can see, as you saw from what Devan showed, like this didn't come all from Google, right? It came from other companies contributing and making those available, and want to encourage that. So there are GitHub repositories where you can find those assets.
Also want to make a shout out to Even Janae, who is the co-founder of Nalin AI. He provides a lot of public material, blogs, and challenges through the Google Cloud blog site that some of these queries are actually coming from too. And I'll share some links in the chat with that.
So the next question got is from Leslie, right? And really interesting one on the architecture side. Like, what are the pros and cons of doing ETL, extract, transform, and load, which is what you saw in BigQuery, versus ELT, extract, load, and transform? So what we mean by that is that if you're talking about extract, load, and transform, basically you load the raw block data right into your store, and that's what you have there stored. And what you've seen in BigQuery is that we actually do a little bit of transformation, and we index the data. And the power of that, as you saw, is that from out of the box, you can do joins, right? You can join table, you can do queries, etc. The data is usable and queryable and supports your, in our case, query needs out of the box without any transformations from the store. Looking at alternative approaches, which also makes sense, is where you load the block data into your store. And that's what, for example, the Coinbase chain stack does. And for example, the Coinbase, I think, open source chain storage. And in chain storage, it's an ELT architecture where you get basically you get the blob block data, and then on top of it, you have like an index or key value store. And the advantage of that is that then you can just, using specific transformers, right, that you have and that the community contributes, then you can transform the data into a format that's going to be useful to you. So that's at a high level the answer, Leslie. I don't know if you had any more, like you wanted to go deeper or take it to a different direction.
No, thank you for the answer.
Very good. And then let's go on to the next question. I think this one is from Leslie again. Are users allowed to query decoded input data? Am I going to be able to access, say, the token movements of a liquidity pool? So
yeah, I can try and take that. Can you hear me?
Yes, we can hear you.
Okay, amazing. Yeah, great question, Leslie. I will share my screen again to give some examples. So short answer is yes, you can query that decoded data. However, it's a pretty advanced move, so you need to really get in there either with UDF functions to really strip out that data, and that could be using regular expressions and the like, or when you dump out query results, use outside tools to do further regex, et cetera, to do more of that unencoding. So you can see my screen here, which is a query I did before, where you're actually querying an actual smart contract call, an ABI call that we store in BigQuery, and you can see that you effectively have nested tables where you might have multiple rows with different results, and you might want to flatten this. But a powerful feature I didn't really share, but I think everyone on the call might find relevant. You can click this option called Export. And if you click on Export with Sheets, we have a product called Google Connected Sheets, where you can support millions of rows inside Google Sheets and have it tie into the back end of Google BigQuery. And this gets really powerful. I just imported 91,000 rows here just for this, just to sort of make a point. But what's really interesting here is you can go through here and then do further decoding. So you can have other sheets and maybe do regular expressions, strip things out.
Thank you, Devan.
Yeah.
So the next question comes from Montreal, from Canada. Can we get a copy of Brice's schema diagram? It will help us join our unique data sets. Brice?
Yes, I can actually, that's no problem. I can download the notebook or share the notebook.
Awesome. It looks like Leslie, we answered your English. Good. And then we answered Azar's question already on non-EVM. So that's what we had, right, for the Q&A in the tools. Any other questions, comments, reactions from the audience? Okay, I think we are looking good. Let me just have one more thing to show you. Let me go back here. Okay, so we just the Q&A, and then Devan also posted in the chat more links, etc. and Brice, right? So you can grab those. We'll share those as well in a follow-up email that Mo will send you. The last thing we wanted to share is just a few links. So the first one is the initial blog post, right? That introduces you with the data set that you saw today. And actually we have two, and then we have a link to the actual data sets as well. But that's going to be from the marketplace featured by blockchain data sets. Then there's a link to the repository for the ETL architecture that you've seen. And then there is a lab around applied data blockchain. So the idea of the lab is that it used to be called Quick Labs, and the idea is that you can get access to an environment where we provision the BigQuery environment, like the query environment that you're going to require, etc. And you can go through the lab in a time-based manner, and then you can try those hands-on and see example queries that we've built there. And then, of course, we have the Google Cloud Web3 Startup Program that you can apply to if you're a startup, and you can get a support from Google and others, as well as Google Cloud credits from that program. So that's what we wanted to share for today. Our next event is going to be in June. Again, if you have ideas, email us about this. I do not see. Okay, comment from Zach. Thank you, Zach, for that comment. Yeah, blockchain analytics. Okay, very good. Do you all have any? Do you want to jump in, comment? Any other questions live, or what are your blockchain needs? Like, are there anything specific that you would need that's not in what you've seen today? Any thoughts related to that? So an archive, yeah, that's coming. All right. Well, we just want to thank you very much on behalf of the presenters and the Google team. Thank you very much for joining today. Thank you for your questions, attention, interactions, and we'll see you next month.